Okay, we're going to pick up where we left off, and we were talking about naming ionic compounds. But before that, we only talked about binary compounds, compounds that had two elements. So now we're going to look at compounds that have what are called polyatomic ions. So you've already done the POGL, and you've seen what a polyatomic ion is. And now we're going to go through how to write the names of compounds that have those polyatomic ions in them. So first off, if we have a polyatomic ion in a compound, always use the name assigned to that compound. Do not change the ending. Remember, in the previous examples, we saw that if we had a compound like CaBr2, then that would be calcium bromide. We would change the ending. But if we have something like CaCO3, we're not going to call that calcium carbon oxide. All right? Instead, this CO3 is a polyatomic ion, and its name is carbonate. So CaCO3 is called calcium carbonate. We do not change the ending on that compound name.
I found something on the web for a polyatomic ion named carbonate.
Okay, apparently Siri thinks I'm talking to her. So hang on just a second. She said that she found carbonate on the web, and indeed she did. So anyways, moving on, as we go to the next slide, it tells us some other polyatomic ion tips and tricks and facts as we move forward. Ammonium, NH4+, is the only polyatomic cation. What does that mean to be a cation? Remember the plus sign right here? So cations are things that have one less electron. So NH4+ is a group with nitrogen and 4 hydrogens that's lost an electron. But the point is that this is the only polyatomic ion you'll ever see at the beginning of a compound. So for example, NH4Cl is ammonium, you just say its name, chloride. There's chlorine on the end, so we did change its ending. It is not part of the polyatomic ion, it's in the compound with it. NO3 negative is nitrate, so if we put that with NH4, NH4 is ammonium, give it its name. NO3 is nitrate, give it its name. Notice this does not have the IDE ending because it has a polyatomic ion at the end. Remember our rules for covalent and ionic? We said that if it's ionic, it'll be a metal with a nonmetal. And if it's covalent, it'll be two or more nonmetals. But look right here. This NH4Cl, N is a nonmetal, nonmetal, nonmetal. Down here again, nonmetal, 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 nonmetal. If you have ammonium in a compound, NH4, it will only have nonmetals in it, but it is still ionic. So this is an exception to watch out for. Ionic is usually metal, nonmetal, but if you have ammonium, it's going to be all nonmetals, but it's still ionic. All right, here they give us some names for polyatomic ions and hints for remembering them. I'm not going to require you to memorize the polyatomic ions. So you're going to have this list that I'm going to print out for you. Hopefully you already have it. And you just need to keep it with you, just like your periodic table. And you can look at this list to see the names of the polyatomic ions. All right, so I'm going to flip through these slides about memorizing, because you don't need to memorize. Okay, so now we're on this slide, naming compounds with polyatomic ions. So we'll practice writing their names. All right, first we've got Cu, which we know is copper, and then CO3. We look on our sheet. CO3 is carbonate. Right? So we've got copper and carbonate. Now, just like we were doing before, we have to figure out, does copper need a Roman numeral? And if so, what should it be? Well, carbonate, from our table, has a -2 charge. and there's one carbonate right here. Alright, sorry I had to pause for announcements, so I'm going to try to pick up where I left off. But carbonate we know has a -2 charge, so in order to balance that, then copper must have a +2 charge. So that makes copper 2 carbonate. For the next one, we have potassium, that's our K, and then SO3. If we look that up on our polyatomic ion sheet, its name is sulfite. Now, potassium only has one possible charge, so the formula, or excuse me, the name would just be potassium sulfite. No need for a Roman numeral because potassium's in group 1. Those are going to be the easiest. All right. Here we have something that we may not have seen, and that's parentheses. So here is what we're looking for the name of, the ClO, and then we have 2 of them to balance with the calcium. So we have calcium. Now calcium's in group 2, so it doesn't need a Roman numeral. And then ClO is called hypochlorite. The 2 is outside the parentheses, so it doesn't go with that formula. It's not part of the name. Calcium and ClO is hypochlorite. The next one, potassium again, group 1, so we don't need a Roman numeral. ClO4 is hyperchlorate, or excuse me, not hyper, but perchlorate. It kind of reminds you of hyper, like you have too much. So when you see a lot of oxygens on something, it'll often be called per. So potassium perchlorate, again, you can get these names off your chart for that one. Sodium's in group 1, so no Roman numeral. ClO3 is just chlorate. So when you add an extra oxygen, it becomes perchlorate, but this one has 3, so sodium chlorate. All right, next one, lithium. Lithium's in group 1, so no need for a Roman numeral. And then NO2 is called nitrite. Lithium nitrite. The next one, lithium again, but now NO3. NO3 is nitrate, so lithium nitrate. And then lastly, we have sodium, and then look at this, CH3COO. All of this is one polyatomic ion, so it has one name. We got to figure out what that name is, but sodium something. All right, so let's look at our chart and see if we can find it. All right, CH3COO. CH3COO. Okay, if you scroll through here, you'll see you don't really see anything written like that. But there's this at the top, C2H3O2. That is the same thing as CH3, C, there's your second C, O, O. Okay, it's just a different way to write the same thing. You might want to write this actually on your sheet so you'll remember these are 2 ways to write the exact same thing, so its name is acetate. So we'll go back to the slideshow. So that name is going to be sodium acetate. And again, sodium doesn't need a Roman numeral because it's in group 1. Alright, so be able to use your polyatomic ion sheet to name compounds and know if they need a Roman numeral or not. I want you now to stop and do number 1 on the worksheet, and then make sure you check with me before you move on.